So today, we're going to get started with our next unit. I do want to acknowledge that the start of this semester has been a little different than what we worked on last semester. Last semester, we saw graphs, we saw functions, we saw lines, we saw some absolute value functions in there, but we looked at equations and we looked at graphs of functions. And we picked out things like x and y intercepts or key features. We talked about transformations when I sort of move those graphs or adjust them in some way. And even though we looked at different units, they all sort of had a common theme there, which was we looked at an equation of a function and we looked at its graph. The first two units for this semester were not really like that. We came back in January and we worked on mean, median, mode, standard deviation. And while we saw graphs in the form of like histograms and dot plots, they weren't the same thing as what we had seen in the fall. And then our last unit over sequences was more focused on identifying those patterns. And while we did see some function-y type things towards the end of our unit when we wrote those explicit formulas, it wasn't quite the same as what we had worked on in the fall. And again, we didn't have that graph component. This unit is going to be more similar to what we worked on in the fall. Okay, so we're going to talk about exponential functions. Our last topic, or our next topic, I should say, after this unit will be quadratic functions. So we'll be back in kind of function world. We're going to see some equations. We're going to see some graphs. We're going to talk about key features. We're going to look at some transformations. The same big ideas that we saw in the fall are going to come back. Okay, so we were in kind of new and different territory for our first couple of units. We're back to function world now. Okay, so for our exponential functions, we're actually going to start today by looking at how those topics that we ended on for our sequences, explicit formulas, the different types of patterns that we recognized in our sequences unit, actually can inform and play into some of the stuff that we're going to look at with our exponential. So on page 1 for your Unit 7 packet, I've got an intro problem for you to take a look at. So this says you're walking along a beach and your toe is something hard. You reach down, grab onto the handle, and pull out a lamp. It's handy, so you start to brush it off with your towel, and poof, a genie appears. He says, "Thank you for freeing me. You can choose one of these two options as a reward." So your two options for reward are purse A, which has $1,000 in it right now, $1,000. If you leave it alone, tomorrow it will contain $1,200. And then the next day it will have $1,400. And this pattern of adding $200 additional dollars per day will continue. What does this sound like? This is similar to what from our last unit? This is an arithmetic sequence. I'm adding $200 every day. That's an arithmetic sequence. Our other option is purse B, which contains 1 penny today. But if I leave that penny there, tomorrow it will turn to 2 pennies. And the next day it will be 4 pennies. And then the amount in the purse will continue to double each day. What does that kind of sound like? This is a geometric sequence. We're doubling, we're multiplying by 2 each time. That's a geometric sequence. So with this in mind, starting with 1,000 and adding 200 each time, or starting with a penny and doubling, multiplying by 2 each time, I would like you to find for me the amount that will be in each purse after 7 days, after a week, after 14 days, so 2 weeks, after 3 weeks, which would be 21 days, and then after 30 days. Okay? Find the total that I'll have in each purse after each of these time periods. As I walked around, I noticed several people, for purse one, adding 200, adding 200, adding 200 for however many days they needed to go, or multiplying by 2, multiplying by 2, multiplying by 2, using that recursive process to figure out the amount of money we'd have after 7 days, 14 days, 21 days, whatever the case may be. I also saw a few people who had written down explicit formulas for each of these sequences. So if I were going to write an explicit formula for purse A, I'm starting with $1,000 and we're adding 200 each day. That would be 200 times n minus 1 plus 1,000. So if I wanted to know how much money will I have after 7 days, I could just plug 7 in for n there, or 14 or 21 or 30. For our geometric sequence here, for purse B, we're starting with a penny and we're doubling each day. So this would be 1 cent times 2 to the n minus 1. Whichever version you chose is fine, whether you use that recursive add 200 times 2 times 2 times 2, or you wrote a formula and plugged in those numbers, you should have gotten the same results. For number 1, for purse A, after 7 days, you should have $2,200. For purse B, after 7 days, we should have 64 cents. Don't spend it all in one place. After 14 days, if we give it another week, for purse A, we should have $3,600. And for purse B, $81.92. So purse A, chugging along quite nicely. Purse B, got about 82 bucks. Now let's give it another week. Let's find those totals after 21 days. So again, if you're using those explicit formulas, that means you're plugging 21 in for n in each of these. For purse A, after 21 days, you would have $5,000. For purse B, after 21 days, so remember a week ago, we had about $82. Now we've got $10,485.80. What happened to purse B? Why is this amount suddenly so big? Because it's doubling, right? So purse A, we're growing by the same amount each time. This arithmetic sequence that we've got here, and arithmetic sequences in general, growing by that constant amount, or if I were subtracting, decreasing by that constant amount, gives me a linear relationship. That's why our explicit formula for an arithmetic sequence looks like point slope form, because it's linear, it's a line, okay? That amount I increase by or decrease by each time acts as my slope. For a geometric sequence, we're growing really slowly at first, right? In a week, I went from 1 cent to 64 cents. And then even that jump from 64 cents to $81, that's a pretty big jump. But still small compared to the amount we have in purse A. But then I go from roughly $82. And remember, we're doubling each day. So the next day I would have $164. And the next day, $300 and something dollars. And then I would have roughly $700. We're doubling each time, which means as I double, I'm gonna see some pretty big jumps, especially over the course of a week. So our gains are small at first, but then they really start to take off. And this is what we call exponential growth. And that's why our explicit formulas for these geometric sequences have an exponent to them. Okay? They're exponential functions. We didn't know what an exponential function was when we talked about these explicit formulas, but we knew if I'm multiplying by 2 a bunch of times, I would use an exponent to represent that. So this is going to be our focus for this unit, this exponential pattern. Okay. So then if we follow this out for another week and some change, 9 more days. So after 30 days, purse A still gaining $200 a day. So we're at $6,800 at the end of 30 days. Purse B still doubling. So we're at about 10,500. So now we would be at about 21,000, right? And then we would double that, and then double that, and then double that. At the end of 30 days, we're at $5,368,709.12. Now, is purse A eventually going to get to $5 million? Yeah, it's going to take a while though, right? Where if I had the patience to stick it out with purse B, if I can just hold on for, well, even at 21 days, we had more money, right? At 30 days, way, way, way more. Okay, so purse A will also get to 5 million eventually, but it's going to take a lot longer since we're adding at that constant rate each time. Questions for me so far? Okay, so again, our focus this unit will be on problems like purse B, this exponential growth that we're seeing here. Functions where I'm doubling each time, or I'm tripling each time, or I'm cutting in half each time. That's going to be our focus. We're going to look at equations, we're going to look at graphs, we're going to look at the parent graph and transformations, we're going to look at key features, We're going to look at problems with a context like what we saw here, but our focus is going to be on these exponentials. And we're going to see some linear problems in there as well, so that we can sort of compare the rates at which we are growing or declining, and take a look at what those different sort of contexts look like, how they're phrased, um, sort of like what we did here, adding 200 each day versus doubling each day. So we're going to see some linears pop up here and there, but mostly so that we can sort of compare to what we're doing with our exponential functions. So exponentials will be our focus for this unit. The next thing I want you to work on are a couple of refresher problems that are going to help us as we continue to work through Unit 7. So on the next page are some what are called skills practice problems. So these are things that you guys have seen before. They just haven't been a big focus recently. So question number 1 is asking you about what 2 to the 7th means. Well, we actually talked about what an exponent represents in our last unit when we were talking about those geometric sequences. We also looked at plugging values into an exponent. We did that with our explicit formula here. If I want to know how much money I have in per C after 14 days, I would plug 14 into that exponent and evaluate. So these are problems that you've seen before, but I just want you to look at as a refresher. And then number 3, we've got a graph here, and it's asking you some questions about what's represented there. We haven't looked at graphs of functions in a little while. So I anticipate the graph function or the graph problem may take you a little bit longer. That's okay. Graphs are going to make a comeback in this unit. So I want you to take the time to ask questions on this, and to make sure that we sort of remember what those key features are, how I find them, what's an x-intercept, what's a y-intercept, all that good stuff that we're seeing in problem number 3. Okay.